It's there. Uh, um, Next computer, I guess, can be touch. Uh, okay. Okay. You go. Right. So you're very good. So you read?
Honestly, yeah.
Okay.
Thank you.
Is this okay or do I need to
What?
is this okay?
Sure. Want to make it bigger, maybe? Not sure how, but. There you go.
Hi everyone, my name is Hisedo Magesing and today my presentation is going to be about technical debt. Oh, okay.
Does it work?
Thank you. Yeah, I think so.
No.
No?
It's basic. Now it's working. Fine, anything.
Sure. So my presentation today is going to be based on technical debt. So we'll begin by understanding what is technical debt. So it's a long-term consequences of prioritizing quick fixes over more efficient solution in software development. It's kind of similar to financial debt in a way that you borrow time now to finish the projects quickly, but later on you pay interest in the form of maintenance, bugs, rewrites, and complexity. Technical debt is not always bad because sometimes it could be intentional by the developers to meet deadlines. So why technical debt happens? It happens most often because of the tight deadlines or pressure to release new features. Or there could be like changing requirements or even the will fix it later mindset, which might cause technical debt. Or there could be like limited resources or skill set. And often, because of the poor documentation or rush architecture decision, also technical debt happens. So types of technical debt. There are mainly four types of technical debt. First is intentional debt. It's like a deliberate debt by developers for releasing features quickly. Next one is unintentional technical debt. It might be because of the lack of skills or poor design decisions. The third one is code decay. It happens most often as like the code becomes outdated and new feature piles up. The fourth one is design debt. It happens mostly because of the poor architecture design. So what are the consequences of technical debt? So as you keep taking on the shortcuts or like quick fixes, the technical debt keeps on accumulating, and the code becomes more harder to maintain and update. And the bugs keep on piling up, so the code might show like unexpected behavior. There might be slower development over time, and there could be delay with the new features. And as technical debt keeps on piling up, productivity decreases, and there might be like increase in long-term costs. And also the code base becomes more fragile and is very risky to change. So benefits of technical debt. So technical debt might not always be bad. When managed, it could lead to releasing quick prototypes. It could also help like startup and small team iterate faster. And if like it's managed, it can be paid off. If it's like managed, then it can be paid off later on. So examples include large companies like Facebook, which tends to accumulate a lot of technical debt because they have to release features quickly and they focus on speed. Whereas companies like NASA is opposite in a way that they accumulate extremely low technical debt because their softwares are mostly reliable on critical missions. And often banking and government government sectors tends to accumulate lots of technical debt because of their outdated system. Programming example. So here is a star programming example of technical debt. As you can see, our class example has like two functions, one method, and there is like two functions inside it. So they are doing two jobs. It adds number and it prints result in the same function, so which is kind of messy. And as like time increases, it becomes like harder to reuse and harder to test. Oh, sorry. So here is more like much simpler and cleaner version of that code. So here, like each method does like only one job. It's easier to maintain, easier to reuse, and easier to test. And even if you change like the printing rules later on, it's easier to change. Yeah, that's all. Thank you.
Thank you. Thank you. Yeah. Yeah, today actually we have like a code freeze and someone was asking me, was changing something today. So he said, why, maybe we should change this. I said, nope, we're not changing. We're only changing two lines. I'm not gonna change anything else. Like, he said, we're only changing the minimum, you know. Yeah. Then when you get older, you need two pairs for bifocals. So, okay, here we go. Okay. Um, okay, so we're off of design patterns and we're moving on to the rest of the book. So today, first I just wanted to start with just a quick review of chapter 4, and then we'll move to chapter 5. Okay, we actually did chapter 4 already, but I'll do it one more time quickly. So basically, the idea of 4 is, actually, I don't even know in the book what they call it. Um, I don't even know the title, but basically, that's all I have from it, in my notes. Um, was that well, actually, it helps because what we're going to be doing today is mostly, excuse me, chapter 5. And in chapter 5, we're going to be doing like diagrams. So UML diagrams. So this is like a good way to start it. Basically, you'll remember the difference between non-functional and functional requirements. Does that sound familiar to everyone? Yeah. So I don't have to go through it again, right? And then we spoke about the importance of quantifying for non-functional requirements, since they're like more like they're non-specific, they're more like general. So you have to like sort of work harder to quantify it. So for example, like the speed, you have to have like a way of a scientific way of measuring the speed. Like you can't just say I need a quick program or the size or how easy it is to use. Like you need a way to, to put a number on it, right? Right, to say that, this is better, this is, this does what you want. Reliability, they give you how much the average time it takes before it fails, um, how long it takes to restart, or portability means, does anybody know what portability means? We already said it once, remember? What portability is? It's it's when you want to take a system from one operating system to another. Remember that? So basically like, let's say it's something written in Java, but if it's working on a Windows computer, there are some parts of it that might not, it might be, will only work on Windows. Even though Java Virtual Machine, they have it on Linux, right? But it might not be, it might be Windows specific, right? So portable would be if someone says, I write code that could run on any platform, any Java. I wrote a Java program that can run any platform, but there's still specific things that might be specific to Windows that you're going to have to recompile. Yes.
Is that like what Docker files are for?
Who?
Docker files?
Uh,
Yeah,
I,
like containers.
I'm not sure. Yeah, I think the Docker containers are more so like to run different, like to have different environments cheaply. Like for example, like someone told me Git. You heard of Git, right? Uses a Linux, runs in Linux. I didn't know that. So I guess when it runs on your Windows computer, it creates a little like container or something that runs Unix. So I think it's more like a separate machine. Uh, yeah, I don't know. I forgot what your question was. Is that why,
Yeah, but there's portability, is that like what we use? Like,
in other words, could you have, I know for a while Apple was trying to have a Windows virtual machine inside of Apple so they could run Windows programs. But I don't think it, but it was like but it was like very slow because at first they had to run and then it had to translate it to Apple. I don't know. I don't think it never took off. But for a while, I don't know if you remember, Apple wasn't doing very well before the iPhone came out. So before, remember pre-iPhone, huh? But I don't think they were doing very well. They were just like, they just had these cheap computers and, I'm not cheaper, expensive computers, high-end computers, but they weren't doing well. Yeah, Windows was like much cheaper, like half price. And so like only like, the elite people were using Apple computers, and Windows was like for, most companies would use, they wouldn't use Apple. It was like more for like designers or stuff like that. I remember like all the design, like Adobe came on only worked on Apple or stuff like that. But so they were for a while they were trying to have Windows programs run on it, so increase the sales. But um, anyhow, but it never took off. Um, and then they came up with the iPhone, and then smartphones, and the what's it called, Android operating system. So they're sort of yeah, they beat Microsoft in in that in the smartphone business. Okay, ethnography, we said was understanding how it's going to be used, not just what the people want, but how, like, understanding like the environment it's going to be used in. So, like we said, like, some people might be using it outdoors, some people might be using it where the internet's slow. Some people might be using it in conjunction with other programs, like we said, air traffic controllers. They might be looking at their fellow air traffic controllers and see what they're doing, and then they'll see if there's like 20 planes coming from from their neighbor. They see it's soon gonna be in their sector, and then they're gonna have to worry about it. Okay. Um, Okay, so then we spoke about, now we're getting to diagrams. So now we spoke about these two. Okay, we'll start with the use case table and the use case diagram. Okay, even though they sound very similar, they're actually two completely different things. One is a use case diagram is a very high level diagram. Okay, a use case table, on the other hand, is a very low level, meaning detailed, technical document. So let's look at let's look at the diagram. So use case diagram is basically only shows four things. It shows the activities being done by your program. Those are the things in the middle, and you could disregard the dotted lines. You don't have to know all that. Um, that's just for people who are, experts in UML, which we're not trying to be. We just want to, do the basic UML. So basic UML is we're just interested in the ovals, which are the activities being done by your program. And then the actors are the people who use the program. So they're outside the system. And we want to see what the actors interact with. Which, in other words, basically, like, let's say you have an accounting program, um, um, right? So different people could use it different ways, right? So payroll is going to use certain modules and account receivable. Yeah, I don't even know what I'm saying, but different people and have different. In accounting, they have some people do accounts receivable, some do accounts payable, some people do the employee benefits, payroll, right? So all those types of people are using different parts of the same program, right? So it's all one system, right? But you have different roles within or different, not really roles, but different uses of the program that they're looking at, right? Not everybody needs the same thing. So just want to, I guess, when you design a system, first you want to see, hey, what do we need it to do? And let's first like draw a diagram like this, a high level diagram, and see who's going to interact with it. Let's decide ahead of time, right? Like for example, the IT department, they don't need to, the software development, they don't need to interact with our accounting program, right? Or let's say the marketing department, they don't need to interact, right? In this picture, there's only a customer, a a credit card payment, etc., interacting with it. There's no marketing department, right? So, these are only people that are going to use the program, and that's who we're going to design it for. So let's say on a test, I might ask you, like, which actor interacts with the most activities? And you would say, what would you say? Which actor interacts with the most people? With the most activities? Remember, actor doesn't have to be a person. It could be, it just means something that interacts with our system, right? So let's see, this guy interacts with
Tie. Like,
the what?
it's like even a tie.
Yeah, yeah, this does three. No, this does one.
Customer.
Yeah, just two-way tie. Yeah, you're right. So 2A ties. That was a bad question. Okay, who interacts the least? That's also a tie. Okay, okay, but you get the idea. Okay, so it's basically just three things to know: the lines showing which activities the actors interact with and what they do. Okay. On the other hand, we have this really where I work. These documents go on and on and on, and includes pictures and screenshots. And basically, it's a detailed discussion of a feature, and it's called the use case table, okay? As opposed to diagram. It's a little misleading because they sound like they're the same thing, but they're actually two different things. And this use case table, like where I work, it's called the use case document or something. And they don't call it neither the name. So it gets really confusing. But what this is something which it spells out all the exactly how a feature should work and exactly what should happen if something goes wrong. So typical, um, uh, we have like for example, we have, where is it? Oh, so example, we do have actors, but we also have like um, oh, I'm sorry, this is wrong. So this would be like a person. Let's say start over here. So we have like a precondition. In other words, so like for example, a precondition would be that in order for our use case to begin, you need certain things to happen. So for example, with a washing machine, we need laundry, dirty laundry, right? Uh, it might also be Sunday or whatever. I don't know. If you do your laundry on Sunday, uh, the goal is to actually the goal would be, and you would have let me just go down for a second. You would have Um, you would have a precondition. You would have, actually, listen, this is the same thing. Trying to think if there's anything I'm leaving out. So oh yeah, so basically oh well, this is it basically. So basically you have the preconditions, which would be like, what do you need for this thing to happen? So in our case, you have dirty laundry and 2 hours available to do the laundry. The basic flow is, if you follow the basic flow, you're gonna basically, that's the way you want it to work, right? Meaning that you do you run it'll be more than just get clean. It would be more like you, wash, let's say, clothes, once and clothes get clean, the machine doesn't break, right? That would be your basic flow. That's like what you want to happen, right? Then you have alternative flow, which where you would detail what happens when something goes wrong. So for example, over here, you would have another flow of what's going to happen when the clothes are still dirty or the machine breaks while I was washing the clothes. Like what's going to happen, right? And then success would be, there's another word for success. We call it, um, another way to call it success or post condition. They use this word also. Um, I guess it depends on your company also. They use different terminology. But the idea of the post condition is that the machine is going to um, it's going to wash in 45 minutes and clothes are clean and no water is dripping from them. So that's here. So if we look at this over here, for example, somebody wants to borrow books. So the precondition will be that um, that the user has their identity card, they has their library card, we call it, right? And has picked up the books to loan, right? So the use case table starts with this scenario where the person is ready to check out, right? They have the library card ready and they have the books they want to check out, right? And they added some other conditions, right? That they don't own any books or they could there's no penalty, whatever it is. Okay, so that's their condition. So once we have those conditions, then um, then um, the librarian opens up their computer, then whatever, it goes through all the different steps. If we find out um, the librarian asks for the library card, the librarian asks for the um, whatever, they enters the data, like it's telling you in excruciating detail everything that's going to happen step by step, right? Um, and then the 9 would be uh, the post condition, which is, so this would be the basic flow, right? Or they call it here the ordinary sequence. So that would be like the success way, the normal, the hope for result, right? This is if everything is working well, right? Like someone comes to check out something from they go to checkout line in the supermarket, they give their stuff. So 99% of the time everything is smooth, right? You hand over the items have a price, you give them your credit card, you sign the machine, and you walk out, right? 1% of the time, or maybe 2% of the time, you'll have a exception where, let's say, when you go checking out your food, there's no price on it. Uh-oh. So then you have to have a way to resolve that. There's no barcode. So you could either just give it to the person for free, or you could ask, hey, somebody look up what's the price of apples here. And the person says, forget it. And not worth the wait. Uh, okay, but that would be an exception. But 98% of the time, 99, or 98, like 1% might be like this exception, that there's no barcode, or over here would be that the person already is not allowed to do it. So what should happen? Um, Again, this is short, doesn't tell you everything that's going to happen, right? A real use case goes on and on for pages and pages, right? So it's usually like 2 or 3 pages and basically it's explaining how something should work and what happens when a problem is encountered. And what was the other one? Then we had another one where, same with a login screen, they want to, the same idea, they want to log in. The precondition is they have a correct password, or they think they have a correct password. Then they enter, and the alternative is that they can't log in, and then the success or the post condition will be that they could they could get into the website. Okay, basically I try to stay away. I don't think I could ever write one of these things because I would be too lazy to go through every step. It's like it's very, very, very detailed. Yeah. Like usually when I get one of these, I call up the person and I say, just tell me what you want. Yeah, I don't have patience to read through all this. Yeah, it's like 3 pages, 3 or 4 pages, and just what do you want? Tell me. So, okay, so that's chapter 4. So now we're going to get more into even more diagrams. Okay, so here we go. So chapter 5. Yet more diagrams. Okay, so we went through this already. Next we have okay, this is we mentioned that remember what's between a high level and a low level diagram? It's the level of detail it's showing, right? High level is just like, like a bird's eye view. And then if you go down into the program, right, you see the classes and all right? It's like the microscope, like when you go down with a microscope, right? So from the high level, you see a person. When you go all the way down, you see their DNA or something. So over here, it's the same idea. So this would be the highest level. This would be the context model. This would show, it doesn't even show your program, but it's alone. It's showing you where your program fits within, this is like the CEO of the company would have this diagram, right? He would say that this is where the circle would be the our program, and everything around it are the things it interacts with, right? So it's a very high level thing. So it's like doesn't really tell like a developer, it's not really any technical information. Just saying like, this is our program and we want it to interact with these things, right? So I'm trying to think, here. So for example, over here would be like you have an online community in the middle, which would be our program. And then it would communicate the people that would interact. How would our program fit within the universe of other programs? It would interact with these different entities or programs. Okay. Okay, so these people but our program is limited to the circle in the middle, right? We're just showing where it fits into, like like someone applies for a job, we say, well, you're gonna work between, with this person, and you're gonna have this person on top of you, and these people are gonna you're gonna report to this guy, and and these people might report to you for something like that, right? So, so we show where you fit into the, into the world, right? So, okay, so that's a context model. That's all there is. So all there is just a circle with a bunch of things around it, squares with arrows going back and forth and stuff like that. Okay, so that's a very simple high level. Then we get to something, we still haven't got to programming yet, but now we're identifying already the, in there's, in the, see, before in up here, we only identified the different activities, but we didn't show like how things work, like the order, like like these are just like very high level activities. But like over here, this is actually from the book, this diagram. We're going to show how, like we're going to zoom in a little bit more and show how the different activities interact with each other. Okay? So this is actually called a UML activity diagram because it's showing you, it's not showing code, but it's showing how the program is going to work. Okay? So this is already a little bit complicated, but there's a lot of information here. So this is what you would do next. Before you even write any code, you would just, design it out, what's going to happen in your program, right? You don't want to just start writing code without knowing what's going to happen, right? So, okay, so how do you read this? So the dark circle, you always start at the dark circle, okay? Or the filled in circle, right? The blue, over here it's blue, sometimes it's black, but you start at the circle over here, and you always end up with a circle with the white space around it. That's called a bullseye, right? That's called a bullseye. So you always start at, I don't know what this is called, just a circle. You always start with the solid circle and you end over here. So the goal is to go from here to here. Now you might have more than one solid circle. You might have more than one end point, right? You don't always have to have, when you start a program, you don't always end up the same place, right? Right, but over here, we're going to have, for this program, or this part of the program, right, where we have one flow, okay? So we're showing, this is not the whole program, but it's showing you one flow within the program, okay? So we're starting again from this solid circle to the bullseye at the end. Okay, now these over here are the activities you're going to do. And then you could see from the arrow, okay, now let me just explain to you. This is from the book, but I'll explain to you what's going on. What's going on is this is a diagram showing the example he uses in the book is a medical system, right? So over here, the medical system is, by the way, he just came out with a new version. Like, I don't think anybody bought the version. I don't know, I was gonna buy the new one, but, he came out with a new version. So maybe fix this diagram a little bit. You'll see, we're gonna see it has a few mistakes that I think are mistakes. Anyhow, so the idea is that you want to put somebody into a mental facility, right? Somebody has psychiatric problems, or they might be dangerous to themselves or to other people, and you want to, you want to detain them. So first step is so if we start over here, the first thing we want to do is we want to confirm that this person is really mentally has issues that needs to be taken care of. Okay, that would be step number one. Then you notice there's a bar over here, right? What this bar means is don't get nervous. We're gonna go over this a lot, so you don't have to worry about it. After a while, you could be able to read this like, like you read English, So this bar basically means that at this point, you could, I forgot what the real name for this is, but it just means that when you come to this point, you could do the next activities that come after this bar, you could do them in parallel. So for example, right after I confirm that this person needs to be placed in the hospital, then I have to do two things. I have two activities to do. I have to inform the patient of their rights and record the detention decision. But does the same person have to do it? Or do they have to be done one after another? No. They could be both done asynchronously or in parallel, right? I don't know if asynchronous is the right word, but they could be done in parallel, right? Meaning that one person could do this, one person could do that, okay? So for example, let's say it takes an hour to inform the patient of their rights, and it takes 2 hours to record the detention decision. How long does it take till I get to the next step over here? It could take only 2 hours, right? Because I could do both at the same time, right? So we don't add the time because it can be done together. Okay, so now what does this line over here mean? Now this line over here has a different meaning than this line over here. This line over here means we're going from one activity and we're able to do multiple activities, right, at the same time. This line over here means that we cannot go any further until both activities have been completed. So we're going to stop over here and wait till all these both activities have finished, have completed. Once they're both completed, then this over here is a uniform symbol for a decision. Okay, whenever you see what's this called? A diamond, right? When you see a diamond, that means we have to make a decision. So in this case, we have to decide, actually, if you look up here, it says whether the patient is a dangerous or not dangerous, meaning do they really, do they need heavy duty hospital? They need like a special hospital, or they could go to general hospital. So if they're not dangerous, then we could go over here, or we could, if they are dangerous, then we have to go to the next step, which is find a secure place. Okay? And so now a decision is where you come in one way and you only exit one way or the other, right? Because you have to either go left or right, right? It's like you come to a fork in the road. That's what it looks like, right? It's like a fork in the road. You have to either go one way or the other way. So a person can't be dangerous and not dangerous. They're either one or the other, right? So we either go this direction or we go this direction, right? Depending on the condition of the patient. And then, okay, and then let's take the bottom flow. So at the bottom, we admit to the hospital and, okay, and then we'll stop over here because remember what we said? We said this is we have to wait over here, okay? Remember we said over here, this is a wait till all the arrows finish. There's actually a bug in his diagram. This should not be a line. This should be a diamond. Okay, because once a person's admitted to the hospital, you don't have to wait for transfer to police station. That doesn't, yeah. It's actually he made a mistake. I think I will see in the new edition if I get hold of it if he fixed it. But I'm pretty sure this line is wrong. Okay, because this line says you have to wait till there really should be a diamond saying that whoever comes here, they exit right away. whatever. Okay, so I'll show you a little bit later. Yeah, there's something, maybe I'll try to do it in paint. I forget, I can't do paint. Um, let's see, let's see if I can find it. There should be a, UML, 3 arrows into a diamond. Do they have an image of that? Where would that be? They don't have it. Okay. I was hoping I didn't have to. I don't want to draw it, but they did. Okay, but the way he did it is wrong. It doesn't make sense because you don't have to wait, right? At this point. But anyhow, the point is you make a decision and then you either go to a hospital or you have to find a secure place. And again, this is wrong because this is really a diamond because you have to make a decision, right? Whether you found a place or you didn't find a place, right? It's not really this should really be a diamond. You know what I mean? Because there's one, you can either go to police station or to secure hospital. It should be a diamond. Okay, so this oval should really be a diamond. And then, anyhow, so then after you either went to the police station or to secure hospital, then you continue to this line. So I told you like the left, this side we'll ignore because it shouldn't really be a bar. But on the right side, it's saying that once you've done any of these three, once you've been to the hospital or police station, secure hospital, or admit to hospital, then you could do these three things in parallel. And once they're all finished, then you're done. Okay, so you have to wait till you inform social care, next of kin, update register, which you could do in parallel, but then you have to wait till they're all done. And once they're all completed, then you're done with the whole process. Yeah,
So the reason, or one of the reasons it's a mistake is because that bar means that everything that's left gets redone in parallel.
yeah, on the right side, you mean over here?
Yeah.
Yeah, on the right side, it's correct.
Right.
What?
Yes, sorry, Bob.
Yeah, what?
Go on, sorry.
Yeah, on the right side's correct, but the left side, you don't have to wait. Like he skipped a,
And the bar means that you should wait for all.
yeah, over here it means you have to wait. Right. And also over here, there's only can only go one way or the other. So it should really be also a decision. You have to make a decision whether you found a secure place or not. I think one of my students might have emailed him and he said something like, he replied, he said that, yeah, that's what I say. He said something like, oh, I'll see, maybe I'll fix it, the next. He said he's not really, doesn't really know UML so well. What?
At least he admits that.
Yeah, it's pretty nice. Yeah, so he said that so I was trying to see if the new edition, he fixed it. Yeah, so, yeah, so, okay, and this is basically what we just did, but so this is what we just said. So this is where, remember we said the dark circle is where you start. This is the activity, the oval. The connector is, where you go next. Okay, remember we said the bar with the two arrows going into it means that we're taking two, I guess concurrent means independent. I'm not sure. And then, whatever, it means you should wait till they're both finished. Okay, and this means, yeah, that's what it means, synchronization bar, where we want to wait till they're both finished, then we continue. Um, and this is the, I'm pretty sure it means to wait also, you have to wait. And then the fork symbol is, remember we said was that one activity could go into two concurrent activities, right? That's what we said that means, right? And then this is a decision. We said this is the end symbol. Okay, then I just did another example. This has to do with reading your email. Okay, so, so basically, yeah, this is actually, I think, more accurate. So over here, like we're talking about, is like showing like when somebody's looking at their email. So when they get their email, they look at is it important or it's junk. And I'm assuming if it's junk, it goes to the junk folder or gets deleted. But if it's important, you go to the read mail, right? You read it. And then after you're done, um, either you deleted it or you read it, then you go to this, oh, this I was talking about before, where you have multiple arrows going in and one going out. So over here, whoever comes first, meaning you don't have to wait for, if there would be a bar here, it would mean you have to both read, it wouldn't make sense, right? So over here, you don't have to wait for the mail to be read and mail to be deleted, right? Whichever one finishes, you just continue, right? Does that make sense? When you have a diamond, you always, you never wait, right? Even if you're going into on top or you're entering, right? Whoever on the top, whichever way you go, and that's it. There's no wait. Over here, also there's no wait. Whichever way you come from, you just continue, right? So that's the difference between this, the merge mode node, and this one over here. Because this one over here is different than diamond because you wait, right? The diamond, you don't wait. You just keep on going, right? This is like basically like, two lanes of a road merge into one road and you just keep on going, right? This is more like, you can only continue, let's say, you need a certain number of things to be done before you continue. So, okay, so this means just whoever comes, then they just keep on going. Okay, whichever direction you come from, you just keep on going. So, like over here, okay, let's write same thing here. So in this diagram over here, whether you come from here or whether you come from here, either way, you just keep on going. There's no wait, right? In fact, over here, there's no wait anywhere. I don't see any wait bars. Okay, doesn't have any weights. Right, you're never waiting for something else to happen. Okay, now let me just explain to you what's going on here. This is the exact same thing as this, except that it's organized a little bit to show it has a little bit more organization, and these things are called swim lanes. Okay, and why are they called swim lanes? Because like when you have a swimming race, right? Each swimmer has to stay in their lane, right? They're not allowed to, go in somewhere. You never in a swimming race, whatever. You never a competition. You don't find people swimming into each other, right? They're all in one row, right? And they all go back and forth. They stay in their lane, right? So here also, we took what could be something that looks like this, and we organized it by something like this, which is okay, but we made it a little bit more organized and we organized it by the person that does the activity. So over here, if you look on the left side, we could see which activities are done by the author, which done by the reviewer, which done by the approver, and which done by the owner, right? So we gave more information than the other diagram. We added more information. So it's the same diagram, same symbols, but just more information. A little bit more information, right? We show, like, for example, we show that the owner is going to be doing basically, forget about the box, the squares. Let's ignore those. Those aren't, we're not good. That's just showing you what's happening to the document, the state of the document. But that's not part of this diagram really. Okay. We're just concerned about the activities. Okay. So basically in this over here, if I would ask you who does the least activities, what would you say? If I make it a little smaller, who does the least activities? What would you say?
What's the guy's name on the bottom?
The owner. Right, the owner. Yeah, it doesn't make a difference. Yeah.
No, glasses.
I don't blame you. No, it's hard to read without the lights on, with the lights on. So, right, so the owner is only doing one activity. So it gives you more information, right? And you could see who's doing a lot of work, who's not doing so much. Okay, so basically, let's read this diagram now. So we start, where do we start? What's the first activity we're going to do? Right, we're going to create, I don't even know what this diagram shows. I think it shows a document. I'm not sure. You're creating a document, adding to the document. So let's say you create a document, okay, and then it goes to the reviewer over here, the second row, and they review the draft. And after they apparently, and then they take it for approval, and they either approve it, in which case it goes over here, or it's not approved and it goes back here to get updated, right? You see that? It goes from approve to either, and you have to make a decision. Either it's going to be approved and then it goes up to here, or it's not approved and it goes back to here to review draft, and then it gets updated, I'm sorry, and after it gets updated, then it gets reviewed, then it gets either approved or not approved. So, by the way, what do you see over here? What does this look like? What could you have? You could have an endless loop, right? That approval says, no, it's not good. You fix it, not good. You could have an endless loop, right? So you can't really say how long, like for example, over here, there's no endless loop, I don't think. So over here, for example, I could give like a max time or a min time, right? I could say the max amount of time this process will take because I know how many activities are involved. So I could give a number for how long it will take to get from here, the max amount of time or the minimum amount of time to go from here to here, right? I could give you that number. Over here, there's an endless loop. So I can't give you a number, right? Because you could get stuck in this loop for who knows, right? There's no way of determining, right? There's no limit, how many times you could get updated, right? So I can't give you a number. If you would ask me how long does it take for this whole activity to get finished, I can't give you a number. I could say it could take forever, right? Or it could never get finished, right? If the reviewer is never going to be happy, it'll never get finished. So you have to write something good. So, okay, but let's say it's approved. So then either review effective. I'm not sure exactly what this means, but either it's going to go back to get updated, or it's going to be obsolete and it's going to archive and then it'll be done. Will be done. I have no idea. I really don't understand exactly what's going on here, but I'm just telling you what the diagram shows, right? It just telling you that it goes from once it's approved to some type of effective thing, which says that, which decides whether it's obsolete or change is still needed. And then somehow it goes to archive and then it's done. So I don't exactly, maybe review effective means that it's good. And I don't know exactly yet, but that's the, but you could basically, you could, in other words, I don't understand exactly what's going on, but I could tell you what activities, how they go, right? That's the point. Yeah, let's try to find let's Google something for fun. And let's just find a activity diagram, see if we can figure it out. A UML. So, is this going to be too, see, the problem is that they make them very, a lot of stuff they add in. And we don't need all of it. We're not doing every single possible, okay. Okay, this I think we could do. So, okay, so over here, we start over here, right? Should I turn off the light? Will be better? Let's turn off the light. See. Okay, so it's a little bit small. So we start over here, but by the customer, right? And we're going to end by the customer, right? So we're going to start so first thing the customer is going to do is going to insert their card. Then they're going to enter their PIN, and then it goes to the bank for authorization. And then either the bank is going to, right, does everybody see how this works? Right, what happens, you have to authorize. We have to decide whether if it failed or was authorized, right? If it's valid, then we allow the person to enter, I guess, the amount they want to withdraw, I guess, because it's ATM. What else would you be doing? Well, I guess you could be entering, but I guess over here you're withdrawing. So you enter the amount you want to withdraw. And in that case, it's going to go back to the bank, and the bank is going to check the account balance. And if the balance is less than the amount, it's going to show the balance, and then it's going to eject the card, and you get out of here, right? So that's if you don't have enough money. But if the balance is greater than the amount, so it's going to go over here, and then two things are going to happen, right? Number one, it's going to debit the account, and number two, you're going to take money from the slot. So those two are going to happen at the same time. And then you're going to go over here. I don't know why this should be a fork also. And I don't know why they used a bar. Anyhow, but you can only do, I don't know why they did it. I don't think this is accurate. So anyhow, so then they come back here, and then they basically show the balance, and again, you get eject card and take card. So, so the ATM doesn't really do much. It only shows the balance and only ejects the card. It's not doing a whole lot of stuff. But most of the work is being done by the customer and the bank. Okay? And then we're done, okay? So are there any endless loops here? I don't think so, right? Because if you do invalid PIN, it just ejects the card. There's no endless loop, right? Either it works or it doesn't. Okay, so I think that's enough for tonight. And then we'll review this a little bit next time, which will be a week from today. and Tuesday is the presentation, the projects, right? So I'll see you online at your time slot. If you're not there when you said you're gonna be, it's okay, because I'll just go to the next person, okay? And just show up some other time. Okay, but please show up. Okay. I'll see you for, see you dinner. On the video. Okay? Have a good weekend.